Here we have four sequences in which a 7-cycle waveform moves a light source on the left to a target on the right. In the upper two sequences, the light source and the target are moving away from one another. In the lower two sequences, the light source and the target are moving toward one another. The upper of each pair of sequences is viewed from the target's frame of reference, and the lower in each pair is from the light source's frame of reference. From the target's frame of reference, the waveform appears to be distorted, giving it a longer or shorter frequency depending on the motion of the source. This is the Doppler effect. This stretching or shrinking does not affect the speed at which the light passes the target. Let's freeze the sequence at the last frame. In the top two sequences, it takes more time for the 7-cycle waveform to pass the target as viewed from the light source than when viewed from the target. We can verify this by looking at the difference in progress that the waveform has made past the target in two different frames of reference. 3 cycles have passed the target in the target's frame of reference, and only 2.5 cycles have passed the target in the light source's frame of reference. In the bottom two sequences, it takes more time for the 7-cycle waveform to pass the target as viewed from the light source than when viewed from the target. So the time has two different values when measured from two different frames of reference. This is time dilation, and there are two factors affecting our measurements of time. The first is the Doppler effect. Notice that in the top two sequences, the waveform is longer due to the Doppler effect. This should slow the passage of the waveform in the target's frame of reference, yet the waveform in the second sequence, the light source's frame of reference, is still slower in its passing of the target. Therefore, the Doppler effect is outweighed by our second factor. This is not true in the bottom two sequences. The Doppler effect shortens the waveform, speeding its passing in the target's frame of reference more than the second factor in the light source's frame of reference. What is this second factor contributing to time dilation? Notice that in the light source's frame of reference, the waveform travels at different velocities relative to the target. This is the second factor to time dilation. So although the speed of light is constant relative to the target in the target's frame of reference, it is not constant relative to the objects in the source's frame of reference.